Okay. All right. So hopefully everybody had a good holiday and you had a chance to recharge your batteries or whatever. So today we are going to, well, talk about the midterm. So I'm going to go over some review of we'll talk about the structure of it and the expectations, and then we'll go over some of the coding stuff. So the coding stuff will make up the majority of your marks. So yeah, today is the 28th. In 2 days is our midterm. But yeah, assignment 3 and tutorial 6 and 7 probably they'll be released tomorrow. They're all done. I just have to double check, reread the specs to make sure I haven't said anything dumb or contradictory or whatever. But yeah, so before we get started, any questions on? All right. Okay, so well, we're going to talk about the midterm. There is a practice midterm that's up there, and it has some code. We're not going to do the exact code. We're going to do slightly different code. But well, a few things about the midterm. First of all, it's out of 35. And out of those, 21 marks are for coding, handwritten code. And 14 are for multiple choice. So most of it is coding. Now, the coding I give you, it is sort of roughly based on your assignments, but a very simplified version. All right, I think I picked up a cold over the holidays or something. When I was young, I never used to get sick, and now I get sick like multiple times a year. It's crazy. Yeah, okay, so most of it's going to be coding. So that's the review today, we're going to focus on the coding part. The multiple choice is, it tends to be, I mean, it's stuff that you may have seen on your assignment, but it tends to be stuff that I pull from the notes that maybe does not get emphasized on the assignment, or it could be on the assignment, but it's stuff that, you know, try and dig out a slightly different corner of a particular topic, right? So basically, study the in-class examples and the slides for the multiple choice, and for the coding, I recommend you kind of do these. Blank pages to write the coding. Yeah, I mean, it's going to be handwritten. There's going to be basically each coding question, there's, I think, 6 coding questions altogether, and each one you have a full page to do it in. Yeah, sometimes I try to like make it a little bit smaller because I'm like, oh, you don't need that much space, but then inevitably something goes wrong and people erase stuff or scratch it out and run out of space. So I try to give you a full page for each one. I think that should be more than enough. Yeah. So yeah, let's talk about this coding question. Now in this, the example that I gave you, which is not exactly what we're going to do, but don't be fooled. All of these questions are the same structure, right? And so the structure is, I have, in this case, a movie class, and this is my sort of low-level entity object, and it contains, you know, some sort of thing I want to keep track of, some information, in this case, about movies that I want to keep track of, their title and their price, and perhaps which ones are on hand and which ones are on sale. So yeah, I have a low-level entity class that basically stores this information and has, you know, maybe a couple of low-level business logic, or not, or you know, in this case, this would be sort of sorting logic, whatever. But really not much. They're very simple. The practice midterm, well, what I gave you here is, I mean, none of these functions are complete. So on the actual midterm, I will ask you to write some of these functions. And when you do it, you should keep things like memory management in mind, right? So yeah, technically this is one question, but you can think of it as, well, I could potentially ask you, I'm probably not going to ask you to write anything in the movie class, right? Or whatever low-level entity class you see, because that's pretty simple and straightforward. You'll just be using that class. But here we have a movie list class, And here I might ask you to write some of these functions, right? Because this is something you've done on assignment 2. And so, ideally you would know how to write these functions and instantiate a backing array that is dynamically allocated and full of movie pointers, right? So the way that we store these things is important in terms of how you implement it. So I might ask you to write, well, I will ask you to write a few functions from here and then a few functions from the MovieFlix class. So essentially you have an entity class at the base, and then you have a collections class, the movie list class that stores the movies, and then you have, for lack of a better term, a control class, right? So the MovieFlix is sort of the highest level, and it's sort of the most abstract in terms of, well, I just want to add a movie, and I'm not really concerned about how that's done. That's done, when I write it, I'll use the movie list class and stuff like that. But so yeah, the MovieFlix is the highest level. It makes calls basically on the, it might create some movies and add them to a movie list in the background in order to implement all of these functions. So we're going to talk about them. We're going to do a slightly different example with slightly different functions. But yeah, that's the essential. Whatever you see on your midterm will look a lot like this. There will be a low-level entity class, there will be one intermediate collection class, and one higher level control class. Okay, so do I know? I do know, actually, but I will give you some hints, all right? I'm not going to tell you all of them. But yeah, we are going to work through sort of what I would consider the important things to know. Yeah. Well, we're going to go over some hints today. Yeah. Okay. Any questions on the high-level structure yet? That's a good sign. Yeah, yeah. Yeah. So it's not, if you can do that, it's not going to be a hard test, right? Some of the multiple choice are a little tricky, but you should be fine. Yeah. Other questions? So what would happen is I'll say like, write this download, well, this is just a getter. So this would be pretty simple, but I'll say write this function and this function, for example. And so you'll just write them. And they're not meant to be long, and they're not meant to be particularly complicated, but of course it's C++, so it's already complicated enough, right? Because you got to understand, well, it's a pointer, and now I have to dereference it here and do an address of in this spot or whatever. So yeah, quite simple. And then there's this piece of code here, which is, and I'll include something like this on your midterm, and this is basically a hint as to, I expect this code to run, right? So if you can run this code and there's no memory leaks or double free errors or other seg faults or weird behaviors, then you're on the right track. You won't be able to run this during the midterm, right? So I do expect you to sort of, do some prep beforehand. But it will be there, just to give you an idea of the things that I should expect to see that it can run without crashing. I'm trying to think here. I feel like I had something I wanted to say and now I forget. All right, but let's go into, oh yeah. So I did actually post, I should post an announcement. So this is the example that we're going to go through in class. I just gave you the header files. Okay, that's all I gave you. So you can, if you've done the MovieFlix example, that's great. You can also try this. There might be some slightly different, at least one different function that you might want to take a look at on this. But we're going to go over that today. All right, so it's a grocery store, and as promised, there is one entity class, right? So grocery item, we just want to keep track of these items. They're very similar to the movie class. It's just sort of a low level, keep track of these things. I have an intermediate collection class, so a grocery list. Basically all the same functions as your movie list class. And then I have a grocery store, which is, again, just the high level. Very, very simple application, right? It's a CRUD, create, read, update, delete. Nothing fancy going on here. So, but you should know how to do it. And this, I should spell groceries correctly. That would be great. All right, so let's go through some of these examples. We're going to start with the lowest level. Yeah, it's posted. It's up on Brightspace currently, right? I just included the .h files, and I'm going to write everything in the headers, right, just to keep things simple. So yeah, grocery. There's enough functionality. I have we're going to write some code, and then we're going to run it and make sure that it runs. We're not going to write everything, but we're going to write enough so we can get a couple simple tests. So there is a constructor, a working constructor that initializes item and price. The equals will work. Less than does not currently work, but that's all right. Is on sale, it sort of works. It returns false. I could fix that if we want. There's a print function here as well. Okay, so that's typically I'm not going to ask you to write anything in the grocery, but grocery list, yes. So the grocery list, if we take a look, right, and again, this is very similar to what you've seen on assignment 2. Well, I want to be able to add a pointer to a grocery item. I want to be able to get a pointer of a grocery item at a certain index or with a certain, not title, but let's see, name, let's call that. Remove something from a certain index or with a certain name. And here I'm going to have a dynamically allocated array of grocery pointers. So you should know how to initialize these things. So I have an int that keeps track of the size, and I have this, which should be pointing to a, well, let's draw it actually in memory, what this is going to look like. So we're going to have our grocery store class. And if we look at our grocery store class, it contains an instance of a grocery list, and it has a name, right? So the grocery list is primarily how we're going to interact. Okay, so in this case, I statically allocated a grocery list. I could ask you, I could do something like this where I say, well, there's now a pointer to a grocery list. Now you have to dynamically allocate one. Maybe we'll do this in this example just for completeness. It's slightly easier if I leave it like this, right? Hopefully you understand. I don't have to call new on this grocery list. This grocery list gets made for me automatically. If I have this grocery list, then I have to make it, right? Using a call to new. Okay, so let's go with this new and improved sort of memory model. Yeah, I won't ask you to write the whole code. I mean, it's an 80-minute exam, and I don't want to. You'll be asked to write 6 functions. That might include definitely includes a copy constructor. I'll tell you that. So we'll go over exactly how to do the copy constructor and sort of the things that you should be looking for. But like constructors, destructors, those are fair game. Any of the functions listed are fair game. And when you write these things, you should keep in mind your memory model. Okay, so now I have a grocery list. Let's just call it a grow list. But it's a pointer, and so I'm going to make a new grocery list that's going to sit on the heap. Okay, so that points to that. And this grocery list also has a pointer to an array that sits on the heap. And that array is going to point to grocery items, or I think I just called them groceries. So the memory model currently looks something like this. If I choose to statically allocate my grocery list, well, you should kind of understand what else is going to happen. But this is going to be useful for knowing, what am I supposed to delete and where am I supposed to delete it? And also, what do I do when I make a deep copy of the grocery store. This will be released basically right after class. I don't know, you have to wait for 20 minutes or whatever for YouTube to make sure that everything looks good, but other than that, it'll be posted right after class. Okay, so this is currently what our memory model is going to look like. So let's write some of these functions. We'll start with the grocery list. Dynamically allocated array of grocery pointers. Groceries. So yeah, let's make well, it's an array of grocery pointers. So the type is grocery star, and it has size max array. Okay, so that goes on the heap. That's our array. And then, of course, I want to also initialize size to be 0. And, you know, double check. There's 2 things here and there's 2 things here. So that's, you know, a good sign. I want to initialize everything in my constructor. Now, this is statically allocated, so, you know, I don't have to call a constructor on it, but I do want to initialize it to 0. Otherwise, it's going to be stuck with whatever garbage is there. And then, well, since we're doing this, you know, this symmetry is always sort of a good rule of thumb. So if I call new in my constructor, then I should call delete in my destructor, and the new, of course, uses this new with the subscript. So I'm going to call the delete with the subscript. As to whether I should delete all the groceries in here, that is up to you. Yeah, yes, you should. And on the test, you will. To keep it simple, I'm doing a header only implementation. So I'm just going to write everything in the header. It's just going to be easier than jumping back and forth. I don't, if, no, unless you have to. Like, there are a couple of situations where you need to, right? So yeah, I don't know. Probably if you know, generally speaking, so this is allowed, right? So I'm not using a member initializer list, so I'm fine if you do this here. If there's ever a situation where you should use it, then of course you should. But generally speaking, that's just remembering to initialize these is going to be a few marks anyway. So you might lose something for not using initializer list, but this is pretty safe bet to do this, at least. Yeah. Other questions? Okay. Let's write this add. Very simple, just add it to the back of the array, but of course I always have to do a bounds check. So I'm going to say if the size is greater than or equal to max array, and I say greater than or equal to because I know my propensity for like introducing bugs. If you said equal to, that would also be correct in this instance. I always run under the assumption that I could have made a mistake somewhere else, and now I'm catching it here, so I want to make sure I cover all the cases, but that's just me. So if the size, well, I'm out of space, right? So I'm going to, well, we can see that it returns a Boolean. It's a good bet that that's an error code, so I'm going to return false here. Right, so that means I was not able to add this grocery item, and then whoever called grocery could maybe delete it if they have to. So in this case now, this looks good. So I'm going to add size points to the next empty element in my array. And so I'm just going to assign G to that next location. And then I'm going to say size plus plus, right? So I'm going to increment it. And then I'm going to return true. Okay, so that's it. You have to remember, though, do those bounds checks, return. If there's a return type, make sure you are returning something. And And if you want to do something slightly more clever here, you're more than welcome, right? Because you could write this as one line like this. That's perfectly okay. I split it into two just for clarity here, but yeah, add kind of simple, I guess, but questions? All right, let's do something else. Let's write this get at index. Again, it's going to be pretty simple. I do want to do this bounds check on the index. So if index is less than 0 or index is greater than size, greater than or equal to size for a get. Greater than or equal to. We're not going to be, I think, super picky about stuff like that. There's other stuff we'll be a little bit picky about, like dereferencing, but yeah, in this case, we're out of bounds. The getter returns a pointer to a grocery item. If I need to send an error code back, it's going to be null pointer. So whatever, this didn't work. So I'm going to send back null pointer, and then you can, whatever, do your, wherever you called this from, you can check for a null pointer and then output an appropriate message. Otherwise, this is pretty simple. Groceries. Great. Like simplest function in the world, but you ask this on an exam and I would not believe the stuff that I get. Oh, it's crazy. But yeah. Questions? Okay. We can also write a get using a here. Yeah, let's do this just for fun. We're going to loop over everything and try to find a grocery item that has that name. I is less than size. Yeah, if. Now, what do I have? I think I have an equals or something, which is, again, maybe not the best choice, but it'll do in this situation. So if I found the thing, well, you know what I'm going to do is I'm going to cheat a little bit here. I'm just going to say, right, this will handle, well, I mean, I don't really need this, but I can do either one, right? So this is, maybe this is a bit overkill. I can just do here, return groceries at I. But that is to say, this is not incorrect, right? I can take shortcuts if they're available to me. All right, questions? Okay. Remove is a little more complicated. So now if I remove something from an array, I have to sort of close that gap. So we'll come back to this maybe a little bit later if you guys are interested. You do have a working implementation, right? It was given to you for your assignment 2. You should have sort of kept that working implementation and changed it just to, like, remove a course or whatever, or a lecture. But yeah, that should do it. Right, I have the option of deleting grocery items in my grocery list destructor. If you do that, make sure you're consistent. I'm going to present a certain memory strategy that I prefer. You don't have to use it. Just make sure you're consistent. But yeah, so I'm not going to delete my grocery items here. I'm going to delete my grocery items in the grocery store because that's where I made them, basically. But yeah, that's grocery list. At least as much as we're concerned with doing right now. Any questions? Yeah. Yes. Well, you have to use whatever is asked of you, but it'll be dynamic. Yeah. Static is, of course, pretty simple in comparison. All right. So grocery store. Let's write a few grocery store Well, if this is a grocery list pointer, then I will have to make a new grocery list, right? It'll go on the heap. Well, that's not what I want. And of course, if I do that, in my destructor, I will want to delete groceries. I also said I probably want to delete all my grocery items. What is going on here? Oh. But we'll get to that. We're going to write the add function first, and then we will, use that as sort of a hint as to what to do there. So add grocery item. Well, I'll just say if my groceries is full. Well, this returns a void, but this is sort of my high level object. So I'm just going to assume that it is also like a view class. I'll just say, no room for more items. So I'm going to give some sort of error message here. You should follow whatever the instructions say. Yeah.
The instructions don't mention any error message.
Yeah, I would say that's, yeah. I believe, but do check make sure you check the comments. So the comments will give you additional hints as to what you should do. Yeah. All right. So, and then we will return. Otherwise, there's room. So I'm going to make a new grocery item. And it is item and price. And then I'm going to try to add it. But if I look at my grocery list, of course, add returns a Boolean. So I'm going to double check that this is going to work. So I'm going to say if groceries item added successfully. Else, item not added successfully. Okay. What else should I do here? So for some reason, this add failed. Yeah.
Why would it fail?
That's true. Yes. Well, we're assuming that we're trying to, so this is an abstraction, right? So I have a list, and let's pretend for a second that I only see the header file. So I know that it can fail. And maybe at some point I switch out the grocerylist.cc and I use another implementation, and something else might go wrong. Like maybe I don't allow duplicates or something like that. So yes, you are absolutely correct. The thing that could go wrong, we've already checked for. But I'm using kind of an unrealistic scenario where I don't know, I'm pretending I don't know what could go wrong. So maybe this returns false. So let's say that it returns false. Well, I made a new grocery item, and now this grocery item has not been added anywhere. So I want to make sure to clean up my memory. Delete G, yeah. What does return with no parameter do? It just does a quick exit. I mean, this is my preferred strategy if I reach the end of the line, rather than, I could have put all of this in an else at the end of this if, but I try to avoid having large or deep blocks as much as possible, right? So I don't want a bunch of nested ifs, because then it starts to get hard to keep track of. So as soon as I reach the end of something, I just jump out. There are people who might say this is a bad strategy, right? And that's fine. They might even be right. At this level, it's not a big deal. So I just return, and then I don't have to do an else, and then all of this can appear, in a block, not in a nested block, but just in the add grocery block itself, if that makes sense. Other questions? Okay, so yeah, this is add grocery item. We make sure to clean up our memory, and yeah, slightly unrealistic, but I do expect you to do this on the test if you're asked to write this function. So yeah, we can add. Let's just do print, and then we should be able to test. Do we already count for alphabetical order in the grocery list? The instructions for grocery list are just to add it to the back of the array. So in this case, they won't be in alphabetical order. That's just, I could ask you to do it in alphabetical order, but in this case, we did not. So let's print our groceries. So for int I equals 0, or get size. And then, well, groceries get I, and then print. So we do have enough here to begin to test our grocery store. We're not quite done because, well, I've only added things. I haven't removed anything. So there's going to be memory leaks, obviously. I haven't deleted any of my grocery items, but we can test it now. Oh, does it say that? Grocery store.h. Oh, it does say alphabetical order. All right, well, just ignore that. The array, yes, my apologies. Yeah, I don't want to tell you anything false about the upcoming midterm, but I'm pretty sure you won't have to worry about that. I don't ask you to add in alphabetical order. It'll just be. Yeah, maybe better I say nothing. Just to, I guess, be prepared for alphabetical order, or at least know. So for stuff like that, and for the remove function, right? I don't expect picture perfect code, right? This is stuff that takes me a couple of tries and some tests to figure out. So I don't expect you to be able to, like, during the exam, write perfect add code, but you should know the basics, right? If I'm adding in alphabetical order, well, you got to find where you're going to add, and then you're going to make room. So you should be able to kind of do those. You should know in broad strokes how to do those. If you're off by one, in an array, like in a for loop or something, you don't quite have the upper bound and lower bound correct, that's fine. We're not going to worry too much about that, okay? Just as long as you know the basics. So yeah, I don't want to, again, I don't want to make any statements that might be not correct. I believe it's funny because I've written so many of these midterms, it's like, yeah, I'm pretty sure it does this, but I'm not like 100% sure because I might have asked for something else on a different midterm and maybe I'm confusing them or. Yeah, the less than would be typically alphabetical order, but it is sort of an example of, again, abstraction. So it defines some sort of order. You don't even need to know what order it is. Typically, I would ask you to keep them in order according to their less than function. Yeah, we're going to write a copy constructor as well. All right, so we have enough to test things. So this should run up to here. Right, I should be able to add a bunch of grocery items and then print out the groceries. And since this is all header only, I should be able to do short, like just a main.cc. I think that works, yeah. So yeah, we added all these grocery items and then printed them out, and that looks good. Of course, there are memory leaks, so we're going to clean those up next, but any questions? Okay. Well, let's write this remove. Even though I haven't written the remove for the grocery list, I'm going to assume that it works, right? So basically, when you're writing these functions, if you're maybe thinking of calling a function that you haven't written, that's fine. Just assume it works perfectly. Okay, so you're allowed to do that. So I'm going to make a call. Well, I want to find this item. Yeah, I guess I have a function I can call. So grocery star goner equals. I have a function that will remove item. This might return a null pointer if the item might not be found. So I'll say like if goner equals null pointer. And once we remove it, we probably want to delete it, right? Again, I called new in the add grocery, so the remove grocery has a delete. Again, that's not a rule, but it's a good rule of thumb. No. Generally speaking, again, I don't ask you to implement anything in the entity class, right? So the less than, you can assume that's already done for you. Right? So you don't have to write any of these functions. You will be asked to write functions in the collection class and in the top level class. And you should understand, right, how you're using memory. Basically, that's one of the main lessons here. Okay, other questions? Okay, so we're going to do the copy constructor. All right, so the copy constructor, it will appear. I think it's worth 6 marks. So you should know how to write it correctly. And it should be consistent with all of your other decisions. So here's our memory model, and we want to make a copy of our grocery store. And in this case, we're doing it, right? We have a grocery store list pointer here. Double check on the test, right? Make sure that if it's statically allocated, then there are some steps that you can skip, and you should know sort of the difference. So I have a grocery list. I'm going to make a new grocery list because I don't want to just have this pointer pointing to that grocery list. That's not a deep copy. I want to have all of my own things. So this is going to be a new grocery list. This grocery list constructor is going to make a new array on the heap. And then I'm going to, while looking at this grocery list, I'm going to iterate over all of the elements, all of the grocery items here, and make copies of them that are added to my list. All right, so let's write that out in the code. Let's call this GS for grocery store. All right, so, well, grocery store, if I look down here, there is a name, so I do want to copy the name. Make sure you do that. That's worth a mark. So name equals gs.name. And this is C++, so I have access to the private member variables here. My groceries, I want to make a new grocery list, right? It's dynamically allocated. If it was statically allocated, I could skip this step. And then I want to iterate over all of the groceries in this grocery store and add them to my grocery list, essentially. So a simple for loop will do. So gs.groceries get size. I think my keyboard has seen better days. Keeps missing keystrokes and stuff. But all right, so I'm iterating over all of them, and as I do that, I want to add them. I'm going to break it down into a couple steps for simplicity's sake. Oh my goodness. Okay, so I've grabbed a pointer to the grocery item that I want to make a copy of and add to my grocery list. So there, now I'm just going to make a copy and add it to my grocery list. I'm going to do all that in one step. New. All right, so there's a lot of small details here, right? So I'm making a new grocery item. It's going to be a copy of this current thing. This current thing is just a pointer, this G, so I'm going to have to dereference it to get back the, please follow the pointer and grab me the grocery item that's in that memory location. And then I'm going to make a copy of it by calling the copy constructor for grocery. There are, of course, different ways you could write this, and they're fine, whatever, as long as they work. One thing that I always get asked is, well, we don't have a copy constructor for the grocery. If I look at this, there's only this constructor. The normal constructor is not getting called here, right? So if I look here, I'm explicitly right here making a copy of this grocery store. So I'm taking this grocery store, GS, and I'm making a copy that I'm calling GS2. And this GS2 is calling only this constructor, this copy constructor. It's not calling this thing. So yeah, we have to, incidentally, this is not correct either, right? This should have initialized the name variable there as well. Okay, so yeah. No, there's no WooClap poll today. Well, unless we get through polymorphism, which seems highly unlikely. So yeah, that'll be next week, I guess. All right, so yeah, this should work. And now let's finish this off as well. So I said in here I want to delete my grocery items. So I'm just going to loop over everything and call delete on it. This leaves my grocery list in a bad state, of course, but I don't care because it's going to be deleted. And there we go. So that should, I should be able to make a copy of the grocery list. And then when my grocery stores go out of scope, they should delete everything. And I should not. I should have no memory leaks and no double freeze. We can try it. So no double free, no error messages. That's pretty good. I made a copy. I didn't do anything with it. We could do something like print groceries. All right, so there's the copy, and at the end, they should be all memory should be released. So I should be able to do something like this. And yeah, there we have it. No memory leaks, no double freeze, no weird Valgrind errors whatsoever. So yeah. All right, so in terms of what you should know, this copy constructor is a big one, right? So know how to do that correctly. There's a bunch of other, like I said, there's a bunch of other ways you could do this. You feel free, as long as they logically make sense, you'll get the marks. Questions? Right. Because it's not actually an array, this groceries, even though it has the same name. Watch out for that, eh? I kind of tend to do that, which I know can be confusing. But this is actually a pointer to a grocery list. A grocery list is a class. It is not an array. It has an array inside a backing array, but the deletion of that backing array is handled in the grocery list class itself, right? So that's called here. But grocery store, grocery list is an object. And so when I want to delete an object, I just use the plain old delete. All right. Questions? Simple, right? If you practice, it'll be very simple. You're going to see, I mean, there's going to be no surprises, right? You're going to see something very similar to this. The only thing I haven't implemented is the remove. And again, you got to close the gaps, but as long as you kind of know, just we're not going to be super picky if I ask you to do something like that. As long as you like copy things in the correct direction and stuff like that, we're not going to worry about off by one errors. Will we get a scanned copy of our midterm back? No, it'll be on assigned 2. So you'll be able to see it online. Oh, sorry, yeah, unless that's what you meant. Yes, it will be scanned into a PDF format, and I'm not sure because I can't actually currently, I can't, what do you call it, imitate a student on assigned 2, so I don't actually know what you guys see. I know what I see, and I assume that you guys see something reasonable. Maybe I don't know if you can download your PDFs or not, but try. Let me know. If you really want a copy, I can send you one. All right, other questions? Okay, let's talk a little bit about the multiple choice. Encapsulation. So it's this one here, which is const. So you should know const. And there's other, I forget what else is on there, but yeah. Well, deep copies, I think, eh? I don't remember. Yeah, I think deep copies. Yeah. Other questions? Okay, so multiple choice. I mean, these are good topics to look at, but of course, all of the topics in your notes are good to look at. But how would you compile an object file, an executable? How do you link? You should know all of those things, right? Basic file building. I can do the remove for you if you like. We can give it a try. I can see if it actually works. Again, I have a hard time with the +1, -1. I have to do some tests, but we can definitely try it. If you want, we'll go through the remove. How would you use a double pointer to pass and return a pointer by reference? So, it's probably a good idea to know that. I can't remember if I included it on this exam, but. Oh, there's one more thing we should write, actually. So I'm going to go over this, and then we're going to write one more function. What type of constructors are there, and what are their function signatures? So no, right? No argument constructors, regular constructors, copy constructors, conversion constructors. You should sort of know their signature and purpose. What are namespaces and how are they used? Right, so there's some simple namespace stuff there, nothing too complicated. How would you dynamically allocate an object? Where in memory are objects stored? Stack or the heap is generally your your two best bets. What's the difference between pass by reference and pass by value? What are the four types of arrays and how would they be implemented? Those are tricky, right? Because there's a lot of like low-level details there. You might see questions like that, though. I would be prepared for that. Object categories, we talked a little bit about sort of at a high level, software design. UML diagrams we talked about. Encapsulation, principle of least privilege. Yeah, and the const keyword. So know those things, but also anything from the notes is fair game. All right, questions on that? Okay, so yes, I'll do the remove, but I want to do one more function before that. This get sale items, right? So here I'm passing in a grocery list. So let's see it. And I apologize for those of you who feel this is all pretty trivial. Kind of is if you're used to C++, this will seem very simple. So I'm going to make a grocery list called sale items. And then I'm going to say gs.get sale items. And I'm going to pass this in as an output parameter. Okay, now there's a couple of important considerations here. So one is, I of course have to know how to implement this function, but two is that this is going to have repercussions in terms of memory, right? Depending on what I do here. Am I just copying in the pointers? And if I'm doing that, then I'm sharing pointers between two lists. And now it's a really bad idea to delete grocery items in my grocery list class. If you do, I don't want to muddy the waters too much here, so I'm not going to. If you have a strategy in mind where you actually delete things in the grocery list class, that's fine. Make sure you're consistent. Make sure this works, right, with your memory model. We're going to write it using the current memory model where I delete things in grocery store, which keeps things nice and simple. So I'm going to iterate over all of the elements in my groceries list. And then I'll say, well, if the current thing is on sale, well, then I want to add it to my grocery list. So list.add. And I'm kind of doing, I'm repeating myself a little bit here, but that's okay. This is a small case. Add, no, groceries.get, sorry. There we go. Okay, so I just iterate over everything in my grocery list. If it's on sale, then I add it to this list of sale items. And since this is passed by reference, that's it. I don't have to do any returns or anything like that. It's an output parameter, and so, yeah, questions? Right, so the biggest thing here is that I am just copying pointers, right? So that will have repercussions on your memory model, possibly. All right, remove, somebody mentioned. Yeah, let's do, all right. I'll do my best here. Let's see if we can get it. So first of all, I'm going to do this bounds checking. Okay. So assuming now I have a legitimate index, what I want to do is grab that thing. So grocery. And then down here, I'm going to return it. And in between, I want to close the gap in my array, right? So, yeah, so let's write that. I'll do the best I can. Make sure. I'm just thinking because, when in doubt, I mean, I guess let's just, when in doubt, it's a good thing to draw it out to make sure that you're doing things in the correct direction. Because if you do them in the wrong direction, well, it's going to be wrong and you're going to erase a lot of data. So if I say remove C or remove that 2, well, it's going to grab C and copy it into the goner, but then I want to copy D over here and I want to copy E over here. And so that should work fine. So I'm going to start at the index itself and copy towards the back, right? If it was an add, I would have to start at the back and move my way towards the place that I want to insert the thing. All right, so I just wanted to double check here, but yeah, so I'm going to start at the index itself, int I index, and I'm first stab at it. I'm not going to worry too much about bounds, whether it's off by 1 or we'll check that stuff out later. I is less than size. I want the basic shape of this function, which is groceries at I equals groceries I plus 1. Okay, so, and on a test, this is fine, right? I'm not going to, so in real life, this probably not going to work, or actually, it'll work okay unless I run off the end of the array here. I think I'm doing one extra move, if I'm not mistaken. So typically the correct thing to do would be this. But on a test, just like getting that far would be enough marks. All right, we can try it, I guess. Removing by name, right? Yeah, so it's not quite going to work. I have to write the other remove function as well. So let's do that really quick. Oh, let's just steal the. So yeah, if it equals name, then, well, what I'm going to do is return, not groceries, I'm going to, there we go. So that should work, right? The last thing I did forget one step here is that size minus minus. I want to decrement the size, but otherwise I've removed something. I've returned the thing, and down here I found the thing and then I just remove whatever's at that index, and then all the work is done over here. Right, so that should work now. I should be able to remove this thing. I guess I forgot something, but item removed. So I removed item C. Item C no longer exists. And if I run it with valgrind, I also have no memory leaks because, well, my sorry, over here. Yeah. Well, when I called this, yeah, it did everything I needed, and then my grocery store, I deleted it. So yeah, everything's been cleaned up, and yeah. So there you go. There's a remove, and I believe it would. I believe that's correct. But again, For yourself, just make sure you're sort of you're starting in the right place at index and you're going in the right direction, which is towards the back of the array as you copy things over. Okay. Questions? All right. So yeah, I think that brings us to the end of the review, unless somebody else has something they want to see. And again, this is right. So it should be kind of clear. Like I have a print movies on sale instead of a get movies on sale, but you should know how to do all of those things. And yeah, it should be pretty clear that this is, not that different from the grocery store example, right? It's almost exactly the same. I just changed like basically the names. Yeah, you can absolutely, well, from grocerylist.h, you mean? Uh, I'm sorry, I'm not sure exactly what you mean. We did reuse it though. So I have this remove function, which does all of the work. And then I have this remove function, which just finds the location of the grocery item that has that name and then calls the other remove function. So yeah, you're allowed to do that. And this call to remove decrements the size and returns the correct thing. Yeah, this is sufficient. Other questions? All right, I spent quite a while on that, but yes, you're right. Remove name. Yes, it is possible that I went through this whole thing. Yeah, good call. It is possible that I went through this whole thing and did not find the correct name. So in that case, I should return null pointer. Yes, very good eye there. I did forget that. All right. Okay, let's I think that's, you have the movie flicks examples, you have the grocery list examples, write the code, make sure you understand how to write the code. If you do that, right, that's worth 3/5 of your mark on your midterm. And I can assure you, you will do pretty well. There still might be some tricky multiple choice questions, but you'll do just fine. Okay. So last class we were talking about polymorphism, which is, well, it's this example. So we had talked about polymorphism, which is where I have a base class handle, say a pointer that points to a derived class object. There will be exactly 14 multiple choice, right? So 14 marks for multiple choice and 21 marks for programming. So yeah, we had all kinds of animals that were all in a hierarchy with animal is the sort of grandparent class, let's say, and then bird and chicken is a type of bird and a bird is a type of animal, and et cetera, et cetera. So we can call the speak functions on each of them individually, which we saw. But then when we do things like we grabbed an animal pointer and pointed to the chicken, when we call speak on that chicken, the chicken does not cluck, the chicken speaks like an animal, right? So 13. Okay, so here's where all I'm using just the variables themselves as the handles. So in particular, let's take a look at chicken little. So she clucks like a chicken when I call speak on the chicken variable. But then I can take an animal pointer and I point it to the little red hen. And when I do that and call speak, then it calls the animal speak function. And if I take a bird pointer, right, because a chicken is a bird, and I point it to the little red hen, well, then the little red hen tweets like a bird. So the behavior at runtime is determined by the handle type, not by the object type. And that is called static binding, and that's the default behavior in C++. But that's not really what we want. We want something a little more clever. We want to use polymorphism. So if I point to any type of animal with an animal pointer, then at runtime, I should be able to determine, well, what is this pointer actually pointing at, and then call the correct speak function based on that. And so the trick to that is, well, that's called dynamic binding, and it's optional in C++, right? In Java, dynamic binding is, you always get it, right? You always get that functionality. But here I'm going to turn it on by using the virtual keyword in the base class. So I'm going to say, well, speak is a virtual function. And what happens is, well, when it compiles, it actually, so when I statically, when I'm using static binding, well, down here I have an animal pointer pointing to the red hen. And so the compiler we call speak. And at compile time, the compiler knows which speak function we're talking about. So at compile time, right, this is going to be a little bit faster. But now when I put virtual here at runtime, at compile time, the compiler has no idea what's going to be there. But at runtime, it can check by looking at the virtual table and see that, oh, this is actually a chicken. So let's make it cluck like a chicken. So I'm going to take that same example and run it again. So right, this is static binding. Everybody is fine up here. Down here with the animal pointer, little red hen speaks. Down here with the animal pointer, little red hen clucks, right? So this is dynamic binding on, and that's dynamic binding off. Down here where I have the bird pointer pointing to the little red hen tweets. Down here where I have the bird pointer pointing to the little red hen clucks, right? So it doesn't matter what the pointer type is now. What matters is the actual object type. So in this case, it's a chicken, so it always clucks like a chicken. And then down here, we even said, well, this also works with references, right? So if I point a reference at my little red hen object and then ask it to speak, well, with static binding, it does the animal behavior, but with dynamic binding, she clucks like a chicken. Okay, so that's it. That's the whole trick. This gives you sort of that the polymorphic quality, the late binding that we find so useful. And all I had to do was add it here, and then, well, this became, a virtual function, and this became a virtual function, and the cat, which we didn't really look at the cat example very much, but this is also a virtual function. So the virtualness is inherited to all of the derived classes. Yep, so the virtual keyword here gives us dynamic binding. With inheritance, it gave us virtual inheritance. And I only have to add it to the base class, but as a courtesy, right, to my fellow developers, I'm going to add it all the way down the hierarchy. So if somebody uses a bird class, they can see this virtual keyword, and then they're like, aha, well, this is a virtual function, but maybe I should check my parent class to see how deep it goes. So we add it all the way down the hierarchy. This does not change the functionality. Everything still works the same. The little red hen always still clucks, but of course, now I'm sort of self-documenting my code, right? I'm giving the user a hint here that, hey, this is a virtual function, and maybe you should check your parent class to see, basically how deep it goes. All right. So yeah, this is an example of late binding or dynamic binding, and all that means is that, when we run this code with static binding, when we call the speak function, the compiler knows exactly which speak function to call. It calls the animal speak function. With dynamic binding, when we run this actually has to do a table lookup, right? It jumps to what's called a virtual table, And it has the address of the speak function that we're supposed to be using for this type. All right, so I think we talked about all this last class. So yeah, static binding and dynamic binding. Well, if I have base class pointing to a base class pointer to a base class object, I get base class behavior. If I have a base class pointer pointing to a derived class object with static binding, I get base class behavior as well. If I have derived class pointing to a derived class object, I get derived class behavior. And if I have a derived class pointer pointing to a base class object, of course, that's an error. I can't have a chicken that points to an animal, right, for instance. So yeah, dynamic binding, we use the virtual keyword on the base class function, and then we do, every time we call that function, we actually jump to a virtual table and look and find the correct address for that function. So you can see here, if we have a boat and we have a sailboat that is a type of boat, we inherit from boat, then, and they each have a print function, right? So here I just have a regular print function. You can see the memory layout. If I then make this a virtual function, and then maybe I override it down here, well, we've added a new pointer into our object, right? So here and here, there's a vtable pointer, and those will be different. In the boat class, this vtable pointer will point to a table, and that table will point to this print function, whereas down here, it'll point to a different table, and that different table will point to the sailboat print function. So that's behind the scenes what you're getting when you compile these up. No, so static binding is, so Java always has polymorphism turned on, right? So you can think of it as in C++, we can say we want dynamic binding turned on or off. We can use static binding. In Java, it's always on, right? So in Java, you always have these virtual table pointers. Well, Java is a little bit different, right? Because it compiles into bytecode, so who knows exactly what's going on? Or somebody does, I don't. I would assume it's something similar to this, but yeah, so dynamic binding is exactly what Java does. It does not do static binding. So function binding is just selecting the correct function to execute. Static binding means we make that selection at compile time. Dynamic binding means we make that selection at runtime. And it has some nice features, right? So polymorphism, this late binding thing, allows us to, this is stuff I've already all mentioned. It allows us to write general algorithms, and then we can introduce new code to it by making derived classes, basically, right? So we'll see examples of that coming up. First, let's look at one of the problems with virtual functions, or as soon as I make things virtual, right? Well, constructors and destructors are just functions. Now, constructors we're not going to make virtual because every constructor is always called. But as it turns out, that is not necessarily true of destructors, right? So destructor might get called if I make it virtual, basically. So let's take a look. So here I have basically the same setup as before. I have a virtual function called speak. I'm going to push my animals onto a vector, right? So a vector just has a backing array. So you've written, collection classes similar to a vector. So this is a vector of animal pointers. And so when I push Al and Tweety, well, let's say Al's already an animal, but when I push Tweety onto the vector, what's going to happen is that I'm going to copy the pointer address, but I'm going to copy it as an animal pointer, not as a bird pointer, right? So what happens is when we do the barnyard harmony here, is that I'm calling speak basically on animal pointers, but because I have dynamic binding turned on, they're all going to sing in their own way. So let's, all right, so yeah, the Tweety bird tweets, chicken says cluck cluck, cat says meow. Fantastic. All right, so also I've added destructors here, and the destructors just basically say when the things are being destroyed. So to start with, we're going to just delete them all sort of manually, right? So not in a loop, which is kind of a pain. But when we do that, well, our animal, just the animal destructor is called. For a Tweety bird, of course, the bird destructor is called, then the animal destructor, which is what you would expect, right? That's what we've seen before. A bird has two parts, a bird part and an animal part. A chicken has three parts, so we get three destructors called. A chicken, a bird, and an animal. And the cat has two parts, so the cat, basically all the parts get destroyed of all the animals when I call the delete functions like this explicitly on those variables. But this can get tedious, right? Maybe I have a big barnyard and a lot of animals. So, well, let's just do this. Let's just loop over my vector. I'm going to grab each of those pointers in turn and call delete on them. And that will be how all my animals are slaughtered. And you'll see a big difference, right? So here the barnyard slaughter starts. Oh, yeah, I didn't say barnyard slaughter, but here the barnyard slaughter starts here. Everybody is, all parts of all the animals are destroyed. But down here, only the animal destructors are called. This is, kind of a big deal. So what happened is that we only have static binding turned on. And you can maybe imagine some of the consequences of that, right? So my chicken might have an egg, and if my egg is dynamically allocated, then I'm going to call new in the constructor, and then I'm going to call delete in the destructor. But in this case, now the destructor never gets called. Okay, so now I have a memory leak because, well, because I looped over my animals and called delete on them. So in fact, if I'm going to do anything like this, if I'm going to have a class hierarchy where I have base class pointers like animal that point to derived class, well, in this case, animals, and I call delete on those things, I really should turn on dynamic binding for the destructor, right? So, and in fact, if you don't, there is actual problems that happen on your next assignment. So let's just run this really quick. So I've turned on dynamic binding. Now when I do the barnyard slaughter, everybody is destroyed the way they should be. Also though, if I do something like this, no, it's fine. There is a weird, I haven't figured out why, but on your assignment 3, what sometimes happens is that you have to turn on the virtual destructors, of course, because you're using polymorphism. But you also have to make all these empty destructors, right? They're going to be empty. And you'll just have to make them all throughout your class hierarchy, because there is a bug that seems to be there when you don't do that. Double free error. I'm not sure what part. So if I called, I commented this out, so that's the only way I could see here that you would get a double free error. All right, so yeah, any other questions? Yeah.
They also just do that by making sure that on the comment. I got some leaks for some.
Right. Instead of like just making an empty destructor.
If it's-
Right. Yeah, it's not that uh yeah, no, that's a good point. So yeah, if you I'm not going to go over it right now because I got to get to my next class, but yeah, there is an alternate way to declare that you have a default destructor. I would have to look into actually all the pros and cons of that compared to just an empty one. But yeah, all right, so that's it for today. Sorry, I got to run, but so yeah, I'll see you next class. It is in this room, and so yeah.